What is new, okay, is domain and range and identifying discrete versus continuous, okay? First thing I want to talk about is called relations. A relation is a set of ordered pairs. Now remember, ordered pairs are always written as x comma y from graphs. X comma y. It's a set of ordered pairs that can be represented, multiple ways. Now, what do we mean by multiple ways? We're talking about graphs, tables, equations, lists, all that stuff. That's what we mean by multiple different ways. Okay. Now, within a relation, we have functions. Okay. Now, a function, which again is a relation, in which every x value, which we call domain, has, and I'm doing this in all caps, only one y value, and we call y values the range. A function is when a relation, which is just a graph, a table, a list of ordered pairs, in which every x value, which now has the vocab term domain, has one and only one y value, which we now vocab term call the range. If every x value only has one y value, then your graph or your table or your list is a function. If not, it is not a function. Now, the first thing we're going to talk about today is two different types of graphs. You have what's called a discrete graph and a continuous graph. We're going to talk about a discrete graph first. A discrete graph is a graph where the points, aka ordered pairs, are, in all caps, not connected. And what you see on the graph is just a bunch of dots. It's just a bunch of dots. Okay? Now, something that can help you remember a discrete graph versus a continuous graph is the word discrete starts with what letter? The letter D. What does the word dots start with? The letter D. Okay? So anytime you see dots, we have a discrete graph. Now, there are two ways that we can determine whether a discrete graph is a function. The first way is called the vertical line test. Which you will hear me refer to it as the VLT. It's not a sandwich. It means vertical line test. Or we can just look for repeated x values. So there's actually two ways to determine whether a discrete graph is a function or not. Okay? Does it pass the VLT, or does it have any repeated x values? Now, domain. How do we identify the domain on paper? Very simple. We list all x values by doing this symbol right here. Okay, we list all the x values. What I have just created here, I refer to it as two things. Either squiggly parentheses or fancy parentheses. Okay, the way in which you write a squiggly parentheses or fancy parentheses, if you don't know, is I'm basically going to do an awkward S. Okay, so I make an awkward S, and then I make like a tiny little awkward 2. And I just connect them. And then on the other side, you make an awkward S, or sorry, an awkward 2, then an awkward S. And that's how you create the fancy parentheses. Now, if domain is a list of all our x values, what is the range? Boom! It's just a list of all the y values. Easy peasy lemon squeezy. Okie dokie artichoke. I don't know any others. Those are the only ones I know. You don't have to suffer anymore. And then there's Tim looking at me like I'm crazy. Yeah, see? Side eye. You think I'm crazy. Okay? Alright. So now we've identified all our key vocab terms. Let's put it into practice. Alright? So I have two graphs here. We're only going to look at the left-hand graph right now. Just look at the left-hand graph. Now this graph has a bunch of what's on it? Dots. Now if you have a bunch of dots, that means your graph is discrete. Now I just want to get us into the practice of identifying continuous and discrete, which I know we're in the discrete page, and I know this is automatically discrete, but I want us to get into the habit of identifying those. So that's why I did that, okay? Now what we're going to do, before I answer any of these questions down here, what we're going to do is above each dot on the graph, I want you to write the ordered pairs for each dot. I'll even do the first one for you as an example. I'll do this far left dot right here. That far left dot is at the location of -5, 1. That's what I want you to do, and I'm going to give you about a minute and a half, maybe less, to do that. Identify all the ordered pairs, and then I'm going to call on y'all randomly to tell me what each ordered pair is. Xavier, I'm going to point to a dot, and I would like you to give me that ordered pair. -3, -2. Okay. Ben, I'm going to point to a dot, and I want you to give me the ordered pair. Perfect. Checkers. Yes. What's another name for 0, 0? Boom. Love it. Okay. Jackson. 2 what? Oh, there you go. All right. Connor. That one. Connor. Aren't you Connor? Caven. I'm an idiot. I am so sorry. Slap me silly. My bad, Caven. I still want the ordered pair, though. 4-6. Still learning names. I apologize. Isa. 5-2. Are you positive about that? You just say no or yeah? My bad, Kevin. I'm sorry. -2. Okay. All right. Now for the actual work that we have to do. Okay. Is this graph a function? Okay. If I look at this, all my ordered pairs that I just listed, do any of the x values, and remember, ordered pairs, the x values are there. Okay, x values come first. Are any of those first numbers in my ordered pairs repeated? No. Because no x value is repeated, this graph is considered a function. No x values repeat. Golly. Now, once you've determined if it's a function or if the discrete or continuous, golly, I couldn't think of the words, okay, then you can list all your values. So I do my fancy squiggly parentheses, all right? And when you do lists, all lists must be in order from least to greatest. So I'm going to start from the very far left because we're talking about x values. The very far left, and I'm going to work my way to the right. So what is the furthest left x value? I kind of sort of heard someone say it. Okay. What's the next furthest x value? Okay. What's the next one? What's the next one? 0. The next one? Next one? Next one? So on discrete graphs, you literally list out the x values. Okay? Now the y values on a graph, on a coordinate plane, y values go which 2 directions? Huh? Up and down. Yes, they go up and down. Okay? So I'm going to start from the lowest y value. Is that on the far downside or the far upside? Yes, Tim. The downside, okay? So the lowest dot I have is at what? Remember, y values come second. So what's the lowest y value? -5. Thank you for y'all using your words. Okay. What's the next lowest? -2. How many -2s do I have here, though? I have 2. When you list out all your x and y values, if you have more than 1, you only have to write 1. I'm not going to put -5, -2, -2. I'm not going to write it more than once because mathematicians, not only do they try to make themselves sound smart with all these fancy words, they're also lazy, which is probably why I'm so good at math. Okay? It's because they're lazy and they want to do the least amount of work as possible. I already have a -2. Why do I want to write 2 of them? I don't. I'm just going to write 1 of them. Okay? So to only write 1 of them of the 2. Here, my next one would be 0. And then help finish it out. 1, 2, and 6. I almost wrote 4. And there you go. Now, this next example, I have dots on a graph. That means my graph is what? Discrete. Again, I want us to get used to identifying graphs. Okay, I want us to get used to identifying graphs. Now again, go ahead and find the ordered pairs, but this time I'm only going to give you like 45 seconds to list all your ordered pairs out above each dot. I'll do this one for you. That is -5, 0 at this dot right here. I need you to do the other 1, 2, 3, 4s. So you got 4 more to do. Lucas, I want to point to a dot. You need to tell me the ordered pair of that dot. Boom. -2, 7. Okay. Riley. 1, 2. Kimura. Nice. -3, -2. Tim! -5, 1. What should go first? 1, -5. There you go. 1, -5. Perfect. Okay. Now we have all our values. Looking at our ordered pairs and looking at the dots, would y'all consider this a graph? Would y'all consider this a graph? Yeah, it's a graph. Duh. Would you consider this graph a function? Why? Because there's 2 1s in the x values. X equals 1 repeats. That's how you write that. X equals 1 repeats. Because at x equals 1 repeats, it is not a function. Very good. Now this time I'm going to give you multiple minutes, aka 2, all right? And you, on your own, get to list out the domain and range. On your own, ready, set, banana. Suave, suavecito. Paquito, paquito. That was painful. Ben! Because you're wide awake and totally able to answer this question, can you tell me the list of all the x values? In order from least to greatest. I didn't hear that last one. 0? Did you say 0? We have an x value at 0? One. Okay. Now, how many total ones are there? Do I need to write them both? No, you just need to write it once. Okay. Let's go. Jose. Tell me all our y values. Yep. Yep. There you go. There it is. Woo! Great job. Okay. Anyone have any questions on discrete graphs? Fantastico. Let's talk about the other type of graphs that we will see, which is called a continuous graph, which is a little different. All right, I will admit it's a little different, but it's easier than what it appears to be. Okay, you're going to think it's crazy, but it's actually easier than what it appears to be. So we just talked about discrete, where you had a bunch of dots. Continuous graphs is a graph where your points, aka your ordered pairs, are connected by a line. So how do you know a graph is continuous? The points are connected by a line. Now that line could be like in the shape of a V, it could be the shape of a U, a C, an N, an S, a 5. Doesn't matter. If there's a line on the graph, it's considered continuous. Okay? Now, how do we determine if a continuous graph is a function? There's only one surefire way, and that is the VLT, which is the vertical line test. The vertical line test is the only surefire way. Now, here's what's different. Here's what's really, really different here. Okay? How you write the domain and range between a discrete graph and a continuous graph. They are totally, completely opposites. So to write a domain, you're going to write. I'm not going to use that word. I'm going to use the least x value. That's a y. I don't know why I just did that. The least x value. Then you're going to do the less than or equal to sign, put an x, and then another less than or equal to sign. And then on the right-hand side, you'll put the greatest x value. So you'll start with the less than or equal to x, which is less than or equal to blank. Okay? What this is basically saying is that x is bigger than the smallest x value, but it's smaller than the greatest value. So aka, x is in between these two values. So if you look at this graph here, our value for x is in between these 2 points, is all that domain is saying. It's between these two areas. Okay? The y value, the range, is the exact same thing. We have the less than, y, less than, right there. We start with that. On the left-hand side goes the least value. And on the right-hand side goes the greatest y value. Okay? It'll make more sense when we actually write it down. First and foremost, identify if this is a function or not. We use the vertical line test, which means I take a straight edge up and down and I just move it from left to right. And I ask myself, does the line of the graph go through the edge more than one time? Huh? So if I put this anywhere on this graph, is this touching this edge twice? No. It's only touching it once. No matter where I go on this graph, it's only touching it once. That means you passed the VLT, which means that this is, yes, a function, and it passes the VLT. All right, so here we go. Domain, I always start with writing less than, x, less than, and then range, I always start with less than, y, less than. The reason why I don't put the equal to, I'm about to talk about it. Just start with the regular old basic less than sign. Make sure you have enough room on the left and to the right of these symbols here to write values down. Now, the strategy that I want you to use is I want you to take your pen, find the very far left edge of your graph, and then draw a line up and down from that location. That's as far left as your line goes. Now, if I look at my x values, remember this is the x value line right here. What's the furthest left at my border? What's the border that I have? -4. So that's the furthest left I go. Do you also see how I put it on the left? Because that's the furthest left I go. Find the furthest right that I go. Draw my border wall. How far right did I go? 1. Now, do you remember in the last unit, we talked about open and closed circles. Do you all remember that? Hopefully, because it was only like a day ago. Open and closed circles. If I have a solid circle, is that an open? Is that inclusive or not inclusive? Inclusive, which means it counts. It's a part of it. So where I have my less than sign, I'm going to put an equal to, because I have a closed circle. Over here on the far side, I have a closed circle, so I put an equal to. That's why we learned that in Unit 1. All right, y values, they go up and down. What's the furthest down that I go? Nice. Do I have an open or closed circle at -2? Closed, so I put a line underneath. What's the furthest up that I go? Open or closed circle. So I put an equal to, underline it. And then that's it. So with the discrete graph, you have to list every single x and y value, unless they repeat. I prefer continuous because you're only finding technically 4 numbers and that's it. The smallest x and y value and then the greatest x and y value. That's it. You're only finding those 4 numbers. I don't need to find 10, 15 numbers. And I don't have to write them all either, thank goodness. All right. This one right here. Same thing, okay? First I need to do my vertical line test. Take your straight edge, go across. So far I'm good, I'm good, I'm good, I'm good. Uh-oh. Do more than one part of the graph cross the edge of the paper? Because of that, this is not a function. Because it failed the vertical line test. Domain, less than, x, less than, range, less than, y, less than. Okay? Start with that. then depending on if I have a open or closed circle, depends if I underline something. So the furthest left I go on the x values is what? Nice. At 0, do I have an open or closed circle? Open. So I'm not going to underline. Look to the furthest right I go. Say it. 4. Good. Do I have an open or closed circle at 4? Closed. So I underline that inequality. Which means I can include 4, and it's everything less than that. What is the lowest y value? Say it louder. -4. Open or closed circle? Closed. How high up do I go? Open or closed circle? Open, so I don't underline it. And then you're done, just like that. Bing, bang, boom. Bob's your uncle. Betty's your aunt. I would love to have aunts and uncles named Bob and Betty. What up, Aunt Betty? All right, let's talk about one more graph, and then we'll move on to the next page. Okay. Here, what is that symbol right there? It's an arrow. Okay. Anytime, I'm going to be down here. Anytime you are presented with an arrow, that means your graph goes on forever. Which means there's no end. The graph just goes, and it doesn't stop. Now, there's no literal number that we use to signify going forever. However, there's a symbol and a theory that we use. Starts with an I. Smarty pants. Infinity, which is basically just a sideways 8. Right, Izzy? Wake her up. Right, wake up, Izza. Wake up! You didn't know it, but we just took a quiz. No reaction. Dang. Thought I'd get a reaction on that one. Okay? We use the infinity sign. So anytime there's an arrow on that side, we use infinity sign. Okay? So let's talk about this one. First of all, do you think this will pass the vertical line test? Yes. So is it a function? Yes. Okay? It does pass the vertical line test. Domain. I have x and then my 2 less than signs on either side. Now my arrow is pointing to my least value side. So my infinity will go on the left-hand side. However, if I go left on a number line, am I going to positive numbers or negative numbers? Negative numbers. So how do I symbolize that? Well, I put a negative in front of the infinity. And this is going to be an equal to because infinity is infinity. Everything counts. Another way, and you'll probably see it on like the STAR test or your benchmark test, instead of saying infinity, some tests will use this symbol. Who remembers what that symbol means? Attaway, checkers. That means all real numbers. Thank you. All right. Looking on the furthest right-hand side, do I have an end point? Does that graph end right there? Do, 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 do. Someone say no verbally. Someone say yes or no verbally. Does the graph end? Yes, because there's a dot. Okay, where does it end at? 4. Okay, is that dot open or closed? Closed. So I use my infinity symbol there, or my infinity equal symbol. I've been flubbing over my words all day. Yes, Jack. Yeah, if you see arrow, it's always going to be considered like a closed circle. All right, so let's look at our y values. All right, what's the lowest I go? Your silence makes me think that y'all all know this 100%. 0. Thank you, Tim. Okay, now I do have a closed circle right there. Okay, now the furthest up I go, I have what symbol? I'm tracing it. Arrow. And then arrows tell us that it is infinite. Means it goes on forever. It's the song that never ends. Have you ever heard that song? I'll play it later. Huh? I can't remember it. This is the song that never ends. It goes on and on, my friends. And then I forgot the next part. All right, let's go to the next page because I want y'all to be able to work on y'all's homework. All right. All right. We're only going to do 2 examples. We're going to do one continuous and one discrete. Okay, we're just going to do one continuous and one discrete. Looking at this graph right here, is it continuous or discrete? Continuous. I'm not going to write the whole word continuous because that's ridiculous. I'm just going to write the letter C. Okay. Why is it continuous? Because it has a what? Lines. It has lines. Okay. Would this pass the vertical line test? Okay. This is an easy one. Yes, you can visually see it would pass. So that means it is a function. Okay. And again, yes, it is continuous. So I put my C there. Okay. My domain. Remember my domain or my x values. Less than and less than there. X values, furthest left, and furthest right. What symbol do I have at the end of those lines there? Arrows. Arrows means infinity. Now, if I go left on the number line, is that positive or negative infinity? Negative. So I got to put negative infinity. And then just like I told Jackson, boom, infinity is automatically inclusive. Now, if you ever get an answer of negative infinity to infinity and beyond. Buzz Lightyear? No? Okay. Did I just date myself at all? Made myself seem old? No, because the new Buzz Lightyear movie just came out. Okay? If you ever get in a negative infinity to infinity, your answer will just be this. That'll be your answer. Just like I told you on the last page. I'm pretty sure we have that on your homework tonight too. All right, the range. When I go to my lowest point, do I have an endpoint? Yes. I can see Daigle's head shaking yes. She is correct, 100%. Okay. Where does that point end at? -5. Okay. Now, do I have an open circle there? No, I have a close. So I put my underlined equal to. What about my top side? Huh? 1? What? I go to my top side. What symbols are up top? Arrows! Arrows means what? Infinity. And I'm going upward, so it's a positive infinity. Cray, cray. All right. This one. Is it discrete or continuous? Discrete. Okay? Would you consider this a function? No. Good job. It would fail the vertical line test, and I have x values that repeat. Speaking of, when we have a discrete graph, how do we write our domain and range? We use a what's called a, starts with L, rhymes with ist, lists. Okay, we list them. We list them. So I want to list all my x values. So I have x values here, here, and here. So technically, I only have 3 locations of x values. I technically only have 3 x value locations. Who can tell me what they're at? Or where they're at? Okay, the next one is, say the one you just said. Okay, and then the last one is at? One, 2, 3. It's 3, Tim. Because this is the starting, this is 0 right here. That's 0, 1, 2, 3. Okay, now y values, I have all these dots. However, I only have 3 y value locations. Okay, what are those y value locations at? -2, I heard it. 1 and 4. Okay, I have 1, 2, 3, 4, 5, 6, 7, 8 total dots. But I have a bunch of repeaters. Did I need to write all the repeaters? No. You only need to write what you need to write. Okay? Turn the page. Last page. It'll be really, really quick. We're only going to do like 1 example of it, or 2 examples. It'll go by quick. How do we determine if a set of points is a function? Do the, that's a T. All right, that's a T, sorry. Do the x values repeat? That's the same way we treat what type of graph? Starts with the letter D, rhymes with discrete. Discrete. So when we are given a set of points, boom, 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 treat it like a discrete graph. So if we're going to treat a set of points like a discrete graph, how do we identify our domain and range? With a what? With a what? A list. And domain is a list of what values? Nice. Range is a list of? Nice. Look at y'all growing as students. Coach Kimball's strategy number 1. Take each ordered pair and underline each x value. And look at only as the underlined parts. Looking at only the underlined parts. Do any of my x values repeat? No. So is this a function? Yes, because no x value repeats. All right? Now we want to list all our x values. You must list in numerical order from least to greatest. So what's the smallest x value that I present to you? Find -8, scratch it out because I don't want to look at it anymore. What's the next smallest? Scratch it out, what's the next smallest? Scratch it out, what's the next smallest? Scratch it out, what's the last one? Finish it with a squiggly parentheses at the end. Now, this is how I identify. I don't underline my y values. I do my half box. I just like doing half boxes. What's the smallest y value? Huh? -7. There you go. Then, -2, -1, 7, and then 8. Yes, I'm speeding through it for time reasons. All right, we're going to look at the one directly below it. Does anyone have any questions? Okay. Looking at the ones below it, I underline the X's. All my X's live in Texas. Do any of my X values repeat? Which one? 2. Because that repeats, is this a function? No, it is not. However, I can still list out my domain and range. What is the smallest X value given to me? Noise. Then what? -4. Noise. Then what? 2. Noise. Then what? Wait a second. Why didn't we list the other 2? Because we don't have to. Yes. Thank you. Because we don't have to. We only need to write one of them. Okay? And then what was it again? Sorry. 8. Okay, cool. Sorry, I got into my rhythm. Okay? So again, you don't have to write a repeating number twice. Just write it one time. All right? And then for time restraints, just because I want to get y'all started, -8, -5, 1, 2, 8. Bam, 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 bam. Questions, comments, concerns, tribulations, hunkle, blah, 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 blah. Sweet, great, wonderful, grand. Oh, that was a loud clap. We are now done with the notes due to time restraints. Okay, I want you to get started on your homeworks.